Hey guys, welcome back to linear algebra. We're still in chapter 1 and this is section 1.3. It's the last section of the chapter. So we're going to do some applications of systems of linear equation. First, we're going to do some polynomial curve fitting. And what I have here basically is if I know 2 points make a line, I have a degree of 1 for lines, right? So y equals mx to the first power plus b. 3 points, you can make a parabola. That degree is 2, right? So y equals a plus, ax squared plus bx plus c, or c plus bx plus ax squared. Now we have endpoints. So endpoints will have a degree of n minus 1. Okay, so how do we do this? Well, first, every polynomial can be written as, we'll call this in this case a sub 0, a sub 1, a sub 2, but basically it's almost like ax squared plus bx plus c and so on. So a sub 0, a sub 1, a sub 2, but x to the first power, x to the second power, and so on. Now this is your first equation, okay? And you notice how everything here is 1. For our second equation, you're going to do the same exact thing, and we're going to have sort of similar, same notation, except for now this is our second x point, and here's our second y point, our third x point, our third y point. So I'm going to begin with a quick example. It's going to say determine the polynomial whose graph passes through the points 1, 4, 2, 0, 3, 12. So to apply what I just showed here, this would be x1, this would be y1, right? This will be x2, this will be y2, this will be x3, this will be y3. So this polynomial, because we have 3 points, I'm going to have it to the n minus 1 or second power. So what I'm going to do here is I'm going to remind myself that these are x's, not the a's, and these are y's, okay? So everywhere I see an x, I'm going to be plugging in a 1, and everywhere I see the y, I'm going to plug in a 4. Same thing for the second point, 2, 0, 2, 2, 0. Third point, 3, 3, 12. And what I did here, guys, and there's probably an easier way to solve it, but I need us to remember how to do row reduced echelon form, okay, or reduced, or just row echelon form, and so on. So I took all of these coefficients, so there's a 1, 1, 1, so that's this. I took the 1, 2, 3, so that's this. I took the 1, 4, 9, that's your next person, and 4, 0, 12, and that's my next person. And the truth is, I used our graphing calculator to figure out how to reduce it really quickly because we already did in section 1 and section 2. I don't want to go through the entire procedure. I used the row reduced echelon form, and I got 24, negative 28, and 8. So 24 is going to be our first constant, negative 28 is our second, and 8 is our third. So we are able to write this in this fashion, okay? And in statistics, when we have linear regression, fitting curves, we actually write the coefficients from smaller, the x variables from smaller to larger. So that's how you pretty much do that. One more example, and I'll do it quickly. This example that I'm using is for really large numbers. So I have something like the year 2011, comma 3, 2012, comma 5, and so on. Okay, pause the video if you need to. When the numbers are really large, you can shift them. I decided to make z equal to x minus 2013. It makes no difference if you use 2014. I just used the midpoint of this, okay? So by doing that, 2011 becomes negative 2, 2012 becomes negative 1, 2013 becomes 0. I'm just plugging it right in here. 2014 becomes 1, 2015 becomes 2. I'm going to create same exact thing, right? We have these polynomials. There's 5 points. And with those 5 points, I'm going to have to the fourth power. I'm filling in now. I'm filling in, this is like the z. This is like the p of z. Or this is like xy, okay? The reason why I'm not using xy, I'm going to show you in a second. So we're still solving for a sub 0, a sub 1, a sub 2, all these coefficients, okay? Once you put these into your calculator, or if you want to do it by hand and reduce it, you're going to get 1, -5/4, and so on. But these are for z, okay? What you want to do is you want to convert z back, and the coefficients will stay exactly the same. But we want to convert z back into x minus 2013 from here. So we have 1 -5/4 z, but that's this, plus 101/24 x minus 2013 squared, and then I stop, but plus 3/4 x minus 2013 to the third minus 17/24 x minus 2013 to the fourth power. So if you didn't have a graphing utility, or if you just, and you wanted to do it quickly by hand, then you want to shorten these numbers, because these numbers are way too large to be doing reduced row echelon by hand. Okay, so once you guys solve for a sub 0, a sub 1, a sub 2, and so on, you come up with the polynomial. All right.